What if I told you there's a technology, kind of a hiding in plain sight in factories all over the world, that could totally slash industrial energy use? Yeah, it's not as famous as solar panels or wind turbines, but it really holds a crucial key to decarbonization. How? By turning a facility's biggest waste product into its most valuable asset. Let's dig in.
So just how big is this opportunity we're talking about? Well, take a look at this number, 51%. That's how much of all energy consumed by U.S. industry is used just to create heat. You know, the heat for everything from pasteurizing milk and drying paper to sterilizing medical equipment. It's just a colossal energy footprint, and pretty much all of it right now comes from burning fossil fuels.
But here's the part that's really astonishing. A huge chunk of that heat, we're talking about 36%, is just thrown away. Yep, vented directly into the atmosphere as unrecovered waste. So that brings up a really big question, right? What if we could capture that wasted energy and put it right back to work?
Well, that is exactly where our hidden hero comes in, the industrial heat pump. Now look, this isn't some brand new sci-fi invention, but applying it at an industrial scale, that is a complete game changer. It's a technology that's designed to do one thing and do it brilliantly: recycle heat.
So, how in the world does it work? Okay, the simplest way to get your head around it is to just think of your refrigerator, but running backwards. Your fridge pulls heat from the inside to keep your food cool, right? And then it dumps that waste heat out into your kitchen. An industrial heat pump uses that exact same principle, just with a much, much bigger goal in mind.
Let's just trace the journey here for a second. The heat pump starts by capturing low-temperature waste heat. That's what you see on the left. This could be from something like cooling water. Then, using this really clever thermodynamic cycle with a refrigerant and a compressor, it elevates or upgrades that energy. The result, over on the right, is a stream of much higher, much more useful heat. The key takeaway here is that it's not creating heat from scratch, it's just efficiently moving and concentrating heat that was already there, just being wasted.
Now, to really understand just how powerful this is, we need to know one key term, the coefficient of performance, or COP. It's actually a simple ratio. How much useful heat do you get out for every single unit of electricity you put in? The higher the COP, the more efficient the machine. It is the single most important metric for any heat pump, period.
And this is where it gets kind of mind-bending. A modern gas boiler, at its very best, is about 80% efficient. That means 20 cents of every dollar you spend on fuel is just gone. But an industrial heat pump, it can have a COP of 4, or even higher. That means for every 1 unit of electricity you put in, you get 4 units of heat out. That sounds like it breaks the laws of physics, 400% efficiency, but it doesn't, because 3 of those units are just recycled energy, captured from your waste heat stream. It's incredible.
All right, so a 400% efficiency rating is amazing in theory. But where can we actually put this technology to work in the real world? Let's take a look at the applications. This chart shows us the real sweet spot for today's heat pump technology. As you can see, they are already a perfect fit for processes that need low to medium temperature heat. We're talking anything below 160 degrees Celsius. And look at the industries that pop up: food, paper, chemicals. These are essential processes like drying, pasteurizing, sterilizing, all huge energy users where heat pumps aren't some future dream. They are a perfect technical match right now.
And in some cases, the benefits actually multiply. Certain processes have what we call a double benefit. Take chocolate manufacturing, for example. You need heat to melt the chocolate, but you also need cooling to set it. Well, a single heat pump can do both jobs at the exact same time, giving you the heat you need while also delivering the cooling you need, all as part of the same hyper-efficient cycle.
So let's just put this all together, a real head-to-head comparison. Next to a traditional gas boiler, a heat pump system isn't just 3 to 5 times more efficient. It runs on electricity, which means, of course, it can be powered by renewables. And because it's modular, you can place smaller units exactly where the heat is needed. That slashes distribution losses and gives you incredibly precise control over your process.
Okay, so if this technology is so great, why isn't it everywhere? And that's a totally fair question. Like with any major shift, there are some real challenges we have to overcome.
The biggest barriers aren't really about the technology itself. They're about people and processes. There's just a fundamental lack of awareness, and that leads to a perceived risk. Plant managers are, understandably, hesitant to try something new on a critical production line. On top of that, integrating these systems takes specialized engineering expertise, and that's in short supply.
And of course, there's the sticker shock. The upfront capital cost can be higher than just replacing an old boiler, even if the long-term energy savings create a fantastic payback.
So, knowing the benefits and the barriers, how can a company actually start looking into this? Well, here's a pretty straightforward plan to see if industrial heat pumps are right for you.
It really just boils down to a 5-step process. First, identify your processes that need heat in that sweet spot, below 160 degrees Celsius. Second, map it out. Go find all the sources of low-temperature waste heat in your facility. Third, assess if the required temperature lift, the gap between your waste heat source and your need, is technically feasible. Fourth, analyze the economics. You got to run the numbers on payback, factoring in energy prices and any incentives you can get. And finally, and this is probably the most important, collaborate. Nobody does this alone. You have to engage with technology suppliers and engineering experts to design a solution that's tailored for your specific needs.
So, we'll end with this fundamental question. For a century, industrial waste heat has been seen as a liability, right? A problem to be managed and just gotten rid of. But technologies like the industrial heat pump force us to completely reframe that way of thinking. That stream of warm water coming off your process, that's not waste, it's a fuel source. It's an untapped resource just waiting to be used. So the real question is no longer if you can recycle your heat, but whether you can afford not to. Is your waste heat a liability, or is it your next great asset?